Welcome back to the Decentralized Application Development Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the world of decentralized systems. Before we begin, I'd like to remind our listeners to visit crashcasts.com, join our Discord community, and if you're enjoying the show, consider supporting us on Patreon. Your feedback and support mean the world to us.
That's right, Sheila. And don't forget to subscribe and rate the podcast on your favorite platform. It really helps us reach more people interested in decentralized technologies.
Absolutely, Victor. Now, let's jump into today's topic. We're currently in Season 1, Chapter 1, and we'll be discussing the key characteristics of decentralized systems. But before we dive in, I have a quiz question for our listeners. What unique characteristic of decentralized systems allows them to continue functioning even if a significant portion of the network fails?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of what makes decentralized systems so robust and resilient. I'm excited to see how our listeners will approach this. There are a few different angles to consider, and I think it'll be interesting to see which aspect people focus on.
I agree, Victor. It's not a straightforward question, and it touches on some fundamental principles of decentralization. Now, to help our listeners understand today's topic better, could you start by giving us a quick definition of what we mean by decentralized systems?
Certainly, Sheila. Decentralized systems are networks or organizations where control and decision-making are distributed among multiple nodes or participants, rather than being concentrated in a single central authority. This distribution is a key aspect that sets them apart from traditional centralized systems.
That's a great starting point, Victor. Now, let's dive into the key characteristics of these systems. I understand that one of the primary features is the distribution of control and decision-making. Could you elaborate on this?
Absolutely. The distribution of control and decision-making is indeed a fundamental characteristic of decentralized systems. In these networks, no single entity has complete control over the entire system. Instead, decisions are made collectively by the participants or nodes in the network. This can be likened to a group of friends deciding on a restaurant for dinner. Everyone has a say, rather than one person making the decision for the whole group.
That's an interesting analogy, Victor. It makes me wonder, though, how does this distributed decision-making actually work in practice? Wouldn't it be chaotic if everyone had equal say in every decision?
Great question, Sheila. In practice, decentralized systems often use consensus mechanisms to make decisions. These can range from simple majority voting to more complex algorithms like those used in blockchain networks. The key is that the rules for decision-making are agreed upon by the network participants and enforced by the system itself, not by a central authority.
I see. So it's not a free-for-all, but rather a structured process. Now, another characteristic I've heard about is redundancy and fault tolerance. Can you explain what that means in the context of decentralized systems?
Certainly. Redundancy and fault tolerance are crucial aspects of decentralized systems. In simple terms, it means that the system can continue to function even if some parts of it fail or are compromised. This is achieved by distributing data and functionality across multiple nodes in the network. If one node goes down, others can take over its responsibilities.
That sounds like it could be related to our quiz question. So, if I understand correctly, it's like having multiple copies of important information spread across the network, right?
Exactly, Sheila. It's similar to how you might keep important documents in multiple places, at home, in a safe deposit box, and maybe even digitally in the cloud. If one copy is lost or inaccessible, you still have others to fall back on.
That makes sense. Now, I've also heard that scalability is a key characteristic of decentralized systems. How does that work, especially when compared to centralized systems?
Scalability in decentralized systems is indeed a fascinating topic, Sheila. In theory, decentralized systems can be more scalable than centralized ones because they can add new nodes to increase capacity. It's like adding more lanes to a highway to handle more traffic. However, it's important to note that achieving true scalability in decentralized systems is often challenging and depends on the specific implementation.
I can see how that could be both an advantage and a challenge. Are there any real-world examples of highly scalable decentralized systems?
Absolutely. One of the most prominent examples is the BitTorrent network for file sharing. It's able to handle millions of users and massive amounts of data transfer by distributing the load across all participants. Another example is the Bitcoin network, which is scaled to handle millions of transactions, although it still faces scalability challenges.
Those are great examples, Victor. Now, let's talk about transparency and openness. How do these traits manifest in decentralized systems?
Transparency and openness are core values in many decentralized systems, Sheila. In most cases, the rules governing the system, the data it contains, and the transactions that occur are visible to all participants. This is often achieved through open-source code and public ledgers. It's like having a glass-walled building where everyone can see what's happening inside, as opposed to a traditional bank with its operations hidden behind closed doors.
That's an intriguing comparison. It seems like this transparency could help build trust in the system. But doesn't it also raise privacy concerns?
You've hit on an important point, Sheila. While transparency can indeed build trust, it can also create privacy challenges. This is why many decentralized systems are exploring ways to balance transparency with privacy, such as zero-knowledge proofs in some blockchain systems. It's a complex issue that the decentralized community is actively working on.
Fascinating, Victor. Now we're nearing the end of our time, but I'd like to touch on one more characteristic: autonomy and self-organization. Can you briefly explain what this means for decentralized systems?
Of course, Sheila. Autonomy and self-organization refer to the ability of decentralized systems to operate and maintain themselves without central control. Nodes in the network can join or leave freely, and the system adapts automatically. It's similar to how a flock of birds can fly in complex formations without a leader directing each individual bird.
That's a beautiful analogy, Victor. Before we wrap up, let's reveal the answer to our quiz question. The characteristic that allows decentralized systems to continue functioning even if a significant portion of the network fails is redundancy and fault tolerance, and fault.
Exactly right, Sheila. This resilience is one of the most powerful features of decentralized systems.
Thank you, Victor, for this enlightening discussion. To summarize, we've learned that the key characteristics of decentralized systems include distributed control and decision-making, redundancy and fault tolerance, scalability, transparency and openness, and autonomy and self-organization. These features work together to create robust, resilient, and transparent networks that can operate without central authority.
It's been a pleasure discussing these concepts, Sheila. I hope our listeners have gained a deeper understanding of what makes decentralized systems unique and powerful.
Absolutely, Victor. And to our listeners, don't forget to visit crashcasts.com, join our Discord community, and if you're enjoying the show, please consider supporting us on Patreon. Your engagement helps us create better content for you. Until next time, keep exploring the world of decentralization.